Let me share my screen. And maximize this as well. Last time we worked with the file distros.txt, and we found it. We can find it at this directory: user local examples, and we have this file here, distros. Content of this file contains a list of Linux distributions, the name, the version, and the release date. And we worked with the commands sort and cut. Now we will see the command paste, which is the reverse of cut. First of all, let's prepare some test files starting from distros.txt. We want it to be sorted. So first, let's sort it. And we will use this command, sort. This is a long sort command, but we explained it last time. We are using three sorting keys. The first key sorts by the third column, but starting from the seventh character, which is this one. So it sorts by year. And the second key sorts by the third column, but starting from the first character. And this is the month. It sorts. The second sorting key is by month, and the third sorting key starts at the fourth character. So it sorts by date. So in overall, this sorts by the release date, distros.txt. And this N is numerical sort. This R is reverse, sorting reverse from the biggest to the smallest. And this D ignores any blank lines, blank characters. And let's store the output of the file, output of the command to this file. Distros by date. .txt. So we see that it is a sorted file. And now we will use the cut command to extract the first two fields from this file, from this sorted file, and we will store it to another file. The fields 1 and 2 from the file distros by date. So we get only the first and the second column, and we will store it to the file versions. Also, let's extract the third column from the first file and store it to another file. Now we extract the third column and store it to the file dates, because the third column is the date. So it contains only the date. And now we will see we will use the command paste. to join this file and this one, to merge them together, or paste first the dates file and then the versions file. We see that it joins the lines one by one. The first line of the first file with the first line of the second file. The first line of the second line with the second line, and so on. So this is what paste does, and we can also store it to another file. Now let's see another command which is called join. Join is similar to paste in the sense that it takes two files and creates a single file by joining them, but it is also similar to the join in SQL queries. So if we have two tables, we can join them using a certain key, so that it will join the line from the first file with the line from the second file, but they should have a common key that is equal. Let's make an example to understand it better. I will extract the first field. This was by date. And we'll store it to distros names. So it is only the first field that contains the names of the distros. Let's join it. Let's use the paste command that we used before to join it with another file. Which file? With the file this contains the column of the date, and this contains the column of the names. And we just pasted them, the first line from this file with the first line from this file, and we create this file. Let's save it also to another file. So, we will use the release date as the key, and this is why we name this file as distros key names. So this is the key field, and this is the field of the names. Let's extract the second column from the distros file. So we are starting from the second column up to the second column. So only the second column. And let's store it in the file. These are the version numbers. And again, let's paste the key column, which is the dates with the version numbers. And let's store it to another file. So this file contains the key column and the version numbers. And the previous file that we created contains the names. And now we will join this file with this one using the first column as the key. Well, we are joining this file with this one. And join by default will use the first column as key. And so it will join the matching lines. So this one has to be equal with this one, and so. So although this join is similar to the join operation of databases, it is not as powerful because these two lines have to be sorted on the key column. So in order for it to work correctly, so it has to be sorted on the date, both of the files. So it is not as powerful as the join command of the databases. Now we will see some commands for comparing text. And in order to compare two files, let's create two sample files, two test files. But I will save the output to the file one dot text, and I will enter simply okay. Let's create a second file. And then Control D. Now we can use the command compare. And it will show the output in three columns. In the first column are only the lines that are in the first file, but not in the second. In the second column, there are the lines that are in the second file, but not in the first one. And in the third column are the lines that are common between the two files that are the same. So this is a simple command because it has the output has to be sorted. So both file 1 and file 2 have to be sorted in order to get the correct results. A more powerful command is the command diff, which makes the differences between two files. For example, diff file1.txt, file2.txt, and so it shows us that this is in the first file only, and this is in the second file only. With the option U, with the option C, with the option C, we can also see some context. Context means that it will also show some lines around the differences. So in the lines from 1 to the fourth line, from the first to the fourth, there is this line which is not in the second file, and this line is on the second file. And another option is U, which is unified output, and it will show in the same place. So this shows the differences in the first file. This shows the differences in the second file. But this one shows the differences in both files at the same place. So this minus means that this line is missing from the second file, and this plus shows that this file is extra in the second file. So this is why it is called unified, this option. And usually when this diff is used to make differences between a program. When we write a program, we find the latest changes that we have done, and we can send them to the author, for example, if we make a change. And usually these options are used to produce a patch file. So this U is unified, this R is recursive in case these are directories, and also these two other options that I don't remember. And so it will create a patch file, and we can store it to a file. And after sending this file to the author of the program, for example, he can apply this patch using the command patch. now it is not working. Anyway, let's move to another command, which is used to do editing of text strings or text files on the fly. And it is, the name of the command is tr, and it is short for translate or transliterate or something like this. And it can be used like this. An example. tr, then it takes two arguments. The first argument is a set of characters, and in this case we define the set of characters as a range, and the second argument is another set of characters, and we define it as this range. And then it will translate the first character to the first one, the second character to the second one, and so on. So this is a range that contains 26 characters, and also this contains 26 uppercase characters. So it will replace all the letters with their uppercase equivalent. We can also replace this range with a character class, like this one, for example, lower in this case. And this can be upper. So this is instead of this range. And actually, this is more general, because if we say from A to Z, it means the English alphabet. But if we have a different language, a different local setting, then this lower and this upper means the lowercase letters of the alphabet of the language that we have selected as local. But in this case, it is the same, because we still use the English language as a locale. Now, these two sets of characters have the same size because they have to be meshed one by one. But what happens if they don't have the same size? For example, the second set of characters is just one character, A. Then all the extra letters in this set will match to the last letter of this set. Let's try it. What if it is AB, for example? So all of them are replaced by B because there is no A. For example, so the first one is replaced by the first one here, but the second letter, which is B, is replaced by the second one, and the third one, which is C, etc., are all replaced by the third by the last character of the second set. And we can use the command tr also with the option D, which means delete. So in this case, it does not replace, but it will delete the given characters. For example, if we say delete E, it has deleted all the E letters in this string. Or for example, delete E and T, for example. Then we see that it has deleted also the T character. So it will delete all the characters that are given in the argument. And there is also another option, which is S, and it can be used to squeeze the repeating characters. For example, so this S means squeeze, and all the A characters will be squeezed to one character, the repeating characters. And also, all the repeating B characters will be squeezed to one character, but for the C, they will remain as they are. For example, if we have instead in this case, no characters are squeezed because there are no repeating characters. So it squeezes only the repeating characters. And as an example, let's see how to use this command PR to build a simple encryption system. For example, we can build the rotation 13. Rotation 13 means that we will replace each letter by the letter that is 13 places later in the alphabet. For example, the letter A will be replaced by, I don't know what is, it is somewhere in the middle of the alphabet. The letter B will be replaced by the next letter, and so on. And if we reach the end of alphabet, then we wrap again from the beginning of the alphabet. And we can do this kind of encryption or encoding like this. And we use PR, and we will replace all the lowercase and uppercase letters, but by this is a range from A to Z. So from here we have 26 letters, and here we have 26 letters. There are two ranges. A will be replaced by N, B will be replaced by M, and so on. And the same for the uppercase letters. And we get something that is kind of encoded. And if we use the same replacement, then we should get the original text back. So we give as input the encoded text, and we get back the original text. Another tool that is very powerful and that is used frequently, especially in script, is SED. And this is a streamline editor. So it is an editor, but for input that comes from the standard input. And then it sends the output to the standard output. But it can also edit files and display the output on the screen, which is the standard output. Let's see some examples. Set, and then we give an editing expression, and this is an S, which means a substitute. So the editing expression is this one, and this one contains this s, which is an edit command of sed, which means substitute, and it will replace front with back, and we get the replaced result. Actually, we are using as separator this slash here, but we can use another character as a separator. What matters is that it comes after the command. For example, the character that comes immediately after the command is used or is interpreted as a separator by sed. So in this case, we are using underscore as a separator instead of slash, and it works the same. This is useful, for example, if the content that is going to be replaced or the replacement has some slashes in between. For example, if we had a slash as part of the content that is going to be replaced, with this separator, it can be misinterpreted as the end of the replacement word. So in this case, we change the separator or the delimiter. When we use a command like this, then this command will apply to all the lines of the input. But we can also specify a range of lines. For example, 1s means that apply this command to the first line, only to the first line of the input. In this case, it works. But if it is 2 applied on the second line, then this is untouched because it is the first line of the input. It will apply this command at the second line. Let's see some other examples. Sed. So this command sed will be applied to this file, to the content of this file, distors.txt, and it will show the output on the standard output, which is the screen. And usually by default, the command sed also prints the content, the original content of the file. But with this option n, we instruct it not to print the original content of the file. And then there is a command, a sed command. This from 1,5 says that we will apply the following command to the lines from the first to the fifth. And the command that will be applied is p, which means print. So it will print just the lines from the first to the fifth. So this 1,5 is a range of lines. We can also specify a file with a search by searching. For example, well, we are using this search pattern, SUSE, and it will apply this command only to the files that match this pattern. It is a regular expression, actually. So the result is that it will print only the files that match this pattern. And we can revert the action of the command by typing this. It will it will print only the lines that do not match. Do not match this pattern. Another example. So we are replacing the letter B by the letter capital B in this input, or in this string. And the result is this one. So we see that this command has replaced only the first occurrence of this letter, and not the rest of them. Not the rest. These two are not replaced, only the first one. If we want to replace all the occurrences, then we add the modifier G, which means global. So in this case, it will replace all the matching patterns in the line. Let's say that we want to change the date format in this file. For example, for the first line, it should be year, month, date. And we can do this with a set command like this. So we apply this command to the file this of the text, and then the expression. This is with a capital A. We are going to use extended regular expression because it is more convenient in this case. Substitute. We are using this hash as a delimiter. Then we are going to match the numbers. For example, for matching this month, we need it to repeat 2 times. And also, we are enclosing it in parentheses. We will see later why. Now we are matching this slash, and that's why we use this hash as a delimiter, because inside the pattern is a slash, and it will make things complicated. We have to escape it and so on. But this way it is simpler. And we want to match 2 other numbers, one after each other. So this matches 1 digit, and this one says that it should match 2 digits. Again, we enclose in parentheses this expression, and then we are matching 4 digits from 0 to 9. 4. Again, we enclose it in parentheses, and now in the replacement, we can use back references. For example, we want each parenthesis can be referenced by number like this. We have 3 parentheses, and this /1 references the string that is matched by this part of the pattern. The /2 references the string that is matched by this one, and so on. But we want the year to be displayed first, and then we add, and then the month, and then the date. Is wrong. So for each line, we have replaced the date with the new format. And set can also use a script file. And this script file can contain set commands. For example, this is a command. And also empty lines are ignored. And then on the first line, the command E inserts something, and this will insert an empty line, and then will also insert this line, and also another new line after it. Then this empty line here is ignored, and then we will replace the date. It's basically the same regular expression, or the same command that we used here. Control X. So let's check it again. And, now we can use this sed script. Sed. We are using extended regular expression. This F means that read the commands from the file distros.sed, and the file that we are going to process, distros.txt. And so this first command has inserted this line with an empty line here, and also a new line here, which is an empty line. And this second command has replaced the old date format with the new one. We can also save this, the output of this command to another command that sometimes can be useful is spell, which makes spell checking of a text file. I have some example files in this directory. I'm copying them here. So it is the quick brown fox jumped over the lazy dog. So there is a spelling mistake here. Let's try command spell check. And so you see that it is an interactive command. It highlights the word that has a misspell and give some alternatives or some options. I will press 1 to replace it with the first option. Cut dot text, and we see that it has been corrected. Also, it also can be used to make spell checking in HTML files, for example. Just an example. Also, other kinds of files or formats. So we have a spell checking here and also a spell checking here. And let's try it. So we see that it detects by the extension file foo.html that this is an HTML file, and it will skip the tags. It will work in HTML mode. We'll skip the tags and we'll only check the text. So I will press 1 to replace the first mistake, and again press 1 to replace the second one. So we see that it has been corrected. Now we will see some commands that are used to create archives. Also to compress the files. Let's create a test file. I will save it on foo.txt. So this is the content of the file foo.txt. And actually, let's see also the size of. So it is 12K, 12 kilo. We can use the command gzip or gnuzip to compress this file. It adds the extension .gz. See, from 12K, it goes down to 2.4K. It has compressed the content of the file. We can use unzip to unzip this file, to uncompress it, and it will create the file foo.txt even if it does not exist. Let's zip it again. There is a command zcat, which is similar to the cat command, but it works on zipped files, on compressed files. In this case, let's try it with this file. To proceed page by page, we pass the output to the command less. And also, there is also a command zless, which is similar to less, but it works on zip files, and it will display the output page by page. similar to the command gzip is the command. So it is another command that can be used to compress files. So we can use this command, zip2. It uses another kind of method of compression. And we see that it has compressed even much more than the gzip file. So it is just 85 bytes. So it makes a better compression. And to unzip it, we can use the command d. Actually, this is a small file. Let's try it again. It is still better from 2.4 to 2.2. It is a better compression. Now we have the command R to make archives. Archives are used for backup. We include inside it all the files of a directory or several directories in a single file. And the name stands for tape archive, something like this, because it was used with tape files. It is a very old command. First of all, let's create a test directory that we can use to archive, to make a test archive. So we have created 100 directories. Let's create some empty files inside of each of these directories. So inside of each directory, there are some empty files. And we can create an archive of this directory like this. This option C is for create archive. And then this option F is for file, the file where the archive will be stored, or how the archive file will be named. And then the directory or directories that will be achieved. There can be several directories. So this is the archive file that is being created. With the option T, R, T, and then F, we can see the table of contents or the content of the archive. So it is a list of the files we can inside the archive. So we can write it like this. And with the option V, if we add the option V, it will be verbose. So for each file, it will also give the details of the file. And the order of these options here, I think it does matter, because if I put the V here, it will be interpreted like this. And so this F requires a file name, the name of the archive that is going to be worked on. And this V does not require an argument. So it is the wrong order of the argument. So we have to keep this in mind, that F should be the last option if we combine the options in a single one, because the file name has to come after it. Now let's see how to extract this archive. Create a empty directory. So the archive file is one directory up, and we can use the command R again, but with the option X for extract, and also the file that is going the archive file. So the option F is read the input from this file, and we see that it has created a copy of the test directory. So it is an exact copy of the test directory, which was put inside this archive, was saved inside this archive file. So we have some more commands, but I think that the time is up, and so let's continue them the next time. But I think that the next week there is a FOSDEM, so I think that we will take this week off, and we'll continue the following week. Let's see if there are any questions in the chat. I don't see any questions. Okay, so if there are no questions, then let's meet again 2 weeks from now, because next week we will not have a meeting. Diego says foo.html content. Foo.html is on you can find it on the directory user local examples. Here is this foo.html that we used for the example. So you can copy it locally and try the commands on that one. Okay, see you in 2 weeks.